Most enterprises rely on an extensive network of suppliers, resellers, vendors, and numerous other business partners to achieve success in the globalized market of today. After all, these partners provide a potential gateway to business opportunities and landmarks that are inaccessible through in-house logistics alone. However, the external data coming in from these partners can become extremely difficult to handle manually. Astera Centerprise offers a suite of tools and features to seamlessly integrate partner data and automate the entire process. Let's explore a use case that demonstrates the process of partner onboarding in Astera Centerprise. In this video, we'll be talking about Wheel Dealers, a fictitious online automotive company. The Wheel Dealers portal provides customers with a comprehensive list of available cars from different dealerships across the United States. The company serves over 1 million customers and has partnered with over 200 dealerships in New England and the Mid-Atlantic, with tentative plans to expand their network with 1,000 new vendors from the Midwest and Northeast. The partner data received by Wheel Dealers is currently handled through a manual ETL process that requires significant input of both time and resources. Using Astera Centerprise, we will be designing an automated integration system that can adequately handle this data and is capable of preparing Wheel Dealers for any imminent expansion. Let's take a look at how it can be done. The first step is to create a project that will incorporate all of the components we will use, such as data flows, workflows, schedules, etc., to orchestrate the process. To open a new integration project, go to Project, hover over New, and select Integration Project from the context menu. Once the project has been created, the Project Explorer will open in the Centerprise client. Right-click on the Project tab and select Add New Item to add an item of your choice. As you can see, we have already added all of the items needed for this project. For instance, this data flow is where we will create the ETL process, whereas these workflows will be used to orchestrate the process for automation. And this synonym dictionary file will be used to address naming discrepancies. To start off, we will design the ETL process for Wheel Dealers in a data flow. We have already created one which we'll be using to extract, transform, and write Wheel Dealers data. Let's take a deeper look at this data flow. As you can see, our ETL process employs the use of several objects from the toolbox. Our purpose is to retrieve the data, present it in a refined manner, and upload it to the dealer database. Let's start with the source object, which in this case is an Excel workbook source object. We have opted to use an Excel format for this demonstration. However, you can use any other source object from the toolbox depending on the format of the incoming files. As you can see, the source object has already been populated with the required fields. We have used a template file for this purpose, but the actual data will be coming in from files from an FTP server. In order to capture those files, we have used a variables object to declare a file path variable that can be used to configure the Excel source object. Let's open the configuration window to get a better idea. On the first screen, we've defined the template file path. Here is the layout of our file, which will be seen in all of the subsequent objects. On the config parameter screen, we've used our file path variable as a parameterized value to define the file path for our source object. As we move forward, we'll see how this variable is used to capture the path of the files coming in from the FTP server. We'll now move on to refining and cleansing the source data, which we have done using two transformation objects, sort and data cleanse, in this data flow. First, we've applied a simple sort to our data. As you can see, the dealer ID has been organized in an ascending order. This makes it easier to query the data in subsequent destinations, significantly easing the load on the integration server. The data cleanse object has been used to further refine our data. Since the records received by wheel dealers are already well formatted, we have only used this transformation to remove leading and trailing white spaces. Next, we'll resolve the errors present in the incoming records and upload the data to the dealer database. We've used the data quality rules object to identify erroneous records. We have specified two conditions, and the records that do not meet these conditions will be flagged as errors. The first condition specifies that the mileage of a used car cannot be null, and the second condition specifies that the transmission of a car cannot be null. After applying this check for errors, we have uploaded the incoming data to the dealer database through a database table destination object. As you can see, some of the element names in the database table destination object are inconsistent with those coming in from the data quality rules object. These discrepancies can be expected given the large amounts of partner data received on a regular basis. Centerprise has matched some of the elements with their counterparts due to naming similarities such as ID and dealer ID. But there are still a few that have not been matched with any others, such as method of payment, SP, date of order, and date of delivery. For these, we can use the synonym dictionary. This handy feature can be used to add alternatives for element names as shown in this example. Once we have defined the synonyms, we can create the remaining mappings by pressing Shift and mapping the parent node of the data quality rules object to that of the database table destination object. The last object in this data flow is a record level log, which has been used to flag the errors that do not meet the data quality rules that were defined earlier. If we preview the output, you can see that the relevant records have been indicated with an error sign. Now that we are done with creating the ETL process for wheel dealers' partner onboarding system, let's move on to orchestrating the process for automation. To orchestrate this process, we have used two main workflows, an inner workflow and the job scheduler. Workflow 1's job is to collect newly uploaded data from wheel dealers' FTP server and download them to the local network, whereas Workflow 2 has been designed to dynamically pick up the input files and feed them to our data flow. Let's take a look at Workflow 1 first. Here, the list FTP directory contents object has been used to capture data from the FTP server. We've specified the FTP connection and remote path, which in this case are fetching some sample datasets. Another important thing to note is that the object needs to work in a loop so that all of the files that are present in the FTP server are fetched. By default, it works in singleton mode, which means that it can only work in a single instance and only one file will be fetched. However, we have changed this setting by right-clicking the object header and selecting Loop from the context menu. This is indicated by the loop icon on the top left, which was initially an S for singleton as per the default setting. Next, we have used an expression object to create a path for the files that are coming in. We've mapped the file name element from the list FTP directory contents object to the expression object, and the file names received from the FTP server have been concatenated with the path of the directory they are present in to create a complete path for the incoming files. This path is then loaded into the inner workflow, which has been incorporated into the main workflow using a run workflow object. Now, let's have a look at the inner workflow. First of all, we have declared a variable by the name of fp to capture the file paths that are dynamically being created by the expression object. As you can see, this variable is visible in the run workflow object. The inner workflow's purpose is to download the newly received files to the local directory while deleting older files to make sure that only fresh partner files are downloaded during each run. For this purpose, we have used two file transfer objects. The first object is being used to download new files, and the second object is being used to delete older files. You can see that the two objects are connected with each other so as to run them sequentially. This means that older files will be deleted once all of the new files have been downloaded. The FP variable has been mapped onto the remote path element of both file transfer objects to provide them with the path of the files that need to be downloaded or deleted. Now that everything in Workflow 1 has been covered, let's move on to Workflow 2. As we mentioned earlier, Workflow 2's job is to capture the path of the files that are downloaded from the FTP server and dropped into a particular folder, and feed these file paths into the data flow that we had designed earlier. To fulfill this purpose, we have used a context information object, which is paired with the file drop functionality of the job scheduler to capture the path of the dropped files. We have incorporated the data flow into this workflow by using a run data flow object. If we look back at our data flow, you'll remember that we had created a variable that was used to configure the Excel workbook source object. As you can see, this variable can be seen in the run data flow object. We have mapped the dropped file path element from the context information object onto the file path variable in the run data flow object, thus dynamically feeding these paths into the data flow. The entire cycle is now complete, and these jobs are ready to be scheduled to run by using the Centerprise job scheduler. Here, we have created two schedules, one for Workflow 1 and the other for Workflow 2. For Workflow 1, we have assumed that partner files are coming in on a bi-weekly basis, specifically on Mondays and Wednesdays. Therefore, we have scheduled this workflow to run on these days every week. Workflow 2, on the other hand, has been scheduled to run whenever a new file is downloaded from the FTP server and dropped into a folder. Here, we have provided the path for that folder. Once these schedules have been set up, the entire process will be executed automatically on Astera integration server. Now that we have orchestrated and automated the partner onboarding process, wheel dealers can rely on this system to efficiently handle their partner onboarding needs. And on top of that, the process can be scaled to match growing business needs in the future. So this is how you can create and orchestrate an ETL process for partner onboarding in Astera Centerprise. Visit our documentation site for more information on how to use Astera Centerprise. Thank you for watching this video.